Hello, I'm Storm Thompson. I've been studying foramen magnum placement in posture since last year because this has been used as a controversial indicator of bipedalism since the 1920s. In my video last year, I mentioned that the DICOM data I was trying to use was giving me a lot of trouble. There are many primate skulls from Kyoto University and Smithsonian in that format, so I put a lot of time and effort into these files. The CAT scans which create DICOMs detect every cavity in the bone and even the very standard platform a skull was placed on when the file was made, shown here on the screen. These features had to be removed manually, one slice at a time, for hundreds of slices for each skull. I tried different software solutions, but couldn't streamline the process, and after processing only a handful of skulls, I abandoned the bulk of the DICOM dataset. So Mom and I collected all the 3D models we could find, about 200 models of living and extinct primate and human skulls, and we're still searching for more. Very few of these were humans or assumed ancestors. Not all of these are of the same quality, and I have to examine every one and make sure I can use them without affecting my results. Many of these files were meant for 3D printing, like this one. It's been smoothed, and that removes detail, which would throw off my results. On this model of Phineas Gage's skull, the jaw hides important landmarks. I found ways to remove the lower jaw from some of these models, but I couldn't fix this on all of them. Some skulls were too partial or damaged to be of use regardless of the resolution of the model. One last hurdle has been that many of the primates came in a proprietary format, 3D PDFs. This gave some trouble, but I found ways to work with this and can use most of them. Once I've got a high-quality 3D skull model, I need to measure it. I want to define the center or centroid of the foramen magnum and the zygomatic processes. Then I want to measure the ratio of the distance between the back of the skull and the foramen magnum to the total length from the back of the skull to the front of the upper jaw. I'm also looking at the geometry of the foramen magnum versus the zygomatic processes. It appears to approach an equilateral triangle in many of the primates. To see how consistent this really is, I'm measuring the angle between the foramen magnum and the zygomatic processes. Looking at the zygomatic process, which is related to the proximal or articulating part of the jaw, might take muzzle length out of the question of foramen magnum placement, and some primates can have long muzzles. Because of perspective, the model's orientation is important for taking any measurements. To be consistent between all the models in different species, I assume the plane defined by the teeth is parallel to the ground, except for gibbons and orangutans that eat upside down and don't seem to care. It seems most people and primates hold their heads level, sitting, moving around, and eating. Otherwise, their dinner would either fall out of their mouths or choke them. I use 3D Slicer to rotate the model to the appropriate position like this. From here it should make sense to use 3D tools to find the center of the landmarks and take measurements, but I found most of the software for 3D files is meant for animation, not research or math. One promising set of tools from the European Virtual Anthropology Network, called Ivan, wouldn't compile for us. After exhausting my possibilities, I decided to take the measurements on a 2D image, so I take a screenshot of the skull's bottom in 3D Slicer and save it as a .tiff. Some of the skulls are missing parts. If the skull is missing part of the zygomatic process, I use GIMP to reconstruct the missing bone with a mirror image from the other side. I color this red so that it is obvious what part was reconstructed. I then use ImageJ to find the centroids of the zygomatic processes and the foramen magnum on the .tiff. I use the freehand selection tool to define the area and get the XY coordinates of the centroid. I repeat this on the zygomatic processes. I then use the multi-point tool to mark where the centroids are. But ImageJ won't save these details in the image, so I have to go back to GIMP to take another screenshot. I use GIMP to measure the ratio of the skull's length to the distance between the foramen magnum and the back of the skull. I use an angle measure tool to find the angles with a bit of simple geometry. I record these values into a spreadsheet in LibreOffice Calc. I'm still collecting and processing these figures and experimenting with different ways of looking at the results. This plot of the Foreman Magnum angle in degrees on the y-axis shows some patterns that are beginning to emerge. Here the pink line represents New World monkeys, the gray line is great apes, the blue line is humans, the red line is the extinct specimens, the cyan line is Old World monkeys. It is interesting to note that humans and extinct fossils are grouped with the Old World monkeys and not with the great apes or the New World monkeys. This shows the geometry of the Foreman Magnum to the zygomatic processes is related to some other adaptation besides bipedal posture. This will be a point of comparison for the significance of any patterns in overall Foreman Magnum placement when I analyze my final results.